rules of partial differentiation. So all are welcome to the S&D College of Engineering, and in previous video we already discussed the terms, the function of the several variables, and the how to find the partial derivative and its notations, right? So in this lecture we'll discuss some rules of partial differentiation. In previous video we also discussed one remark, that is all the rules which are defined for the ordinary derivative all are applicable in the partial derivative. So here one by one we will see. Let u and v are the function of two independent variables x and y. So the first rule is, if k is a constant, then dabba by dabba x, k into u is a function of two independent variables, so which is equal to k into dabba u by dabba x. That is, we take the constant k outside the partial derivative. So this one is for the partial derivative with respect to x, and this one is to be defined for the partial derivative with respect to y. So this rule is also defined in the ordinary derivative. Whenever we find the ordinary derivative, we always take the constant terms outside the derivative. So next one, the derivative of sum, that is a partial derivative of sum. So whenever in the two function u and v, in between them there is addition or subtraction, then the partial derivative with respect to x is to be find out, which is equal to dabba u by dabba x plus minus dabba v by dabba x. That is, we separately find the partial derivatives of u and v. The plus minus sign is remain as it is. So this rule is also defined in the ordinary derivative. Whenever in between the two function there is addition or subtraction, then in that case we differentiate both with respect to the x, and whatever the sign addition or subtraction we keep as it is. So same here in the partial derivative for with respect to x and with respect to y. Next, the rule for the derivative of partial derivative of the product. If in between the two function there is a product or multiplication is there, so the first we see the partial derivative with respect to x of u into v, which is equal to u, we keep u as it is, we take the partial derivative of v with respect to x plus v as it is, take the partial derivative of u with respect to x. Similarly, the rule is defined for the partial derivative with respect to y. So all of we are familiar with this multiplication rule of the ordinary derivative, and same rule which is for defined for the partial derivative also. Next, the quotient rule for the partial derivative, that is dabba by dabba x u upon v, which is equal to v into dabba u by dabba x minus u into dabba v by dabba x divided by v square, which is a partial derivative with respect to x. The quotient rule for the partial derivative. So the same rule which is for the with respect to y, partial derivative with respect to y. We all of know the quotient rule for the ordinary derivative, and in similar manner here the rule is defined for the partial derivative. Here there are some partial derivative of the composite functions are given. So see here, let f and g both are the function of x and y. So the first rule That is, if we have to given the constant function and we find the derivative of the constant with respect to x or with respect to y, so the partial derivative is to be 0. Next, if we have to given the function of xy is in only function of y, and we differentiate this only function of y with respect to x partially, then its derivative is 0. And if the function of xy is to be given is in the form of only function of x, and we differentiate this only function of x with respect to the y partially, then its derivative is 0. Next, dabba by dabba x of f of xy raised to power n. If the function of xy is to be defined in this form, then the partial derivative is to be find n into f of xy raised to power n minus 1 into dabba by dabba x. That is the ordinary derivative formula, derivative with respect to x, x raised to n. Here we have to use n into x raised to n minus 1. So instead of x, here the function of two variable is to be given. So for function of two variable, the formula is n into f of xy raised to the power n minus 1 into the partial derivative dabba by dabba x if we differentiate the function with respect to x. Similarly, the formula for partial derivative with respect to y, only change in here we take the derivative of f with respect to y. If the function is in the form of 1 upon f of xy and we have to differentiate the function with respect to x partially, then the derivative is minus 1 upon f of xy bracket square into dabba by dabba x. The similar formula is to be defined for the dabba by dabba y. Next, fifth one, partial derivative of square root of f of xy, which is equal to 1 upon 2 root f of xy into dabba by dabba x. The same formula is for the partial derivative with respect to y is defined. Next, the partial derivative of log of f of xy with respect to x is 1 upon f of xy into the partial derivative with respect to x, the function f. Similar formula is for the partial derivative with respect to y. Only difference is here the derivative is with respect to y. Next, for the exponential function e raised to f of xy. So the derivative, partial derivative of e raised to f of xy with respect to x is e raised to f of xy into dabba by dabba x. Next, at the partial derivative a raised to f of xy is equal to a raised to f of xy into log a into the partial derivative dabba by dabba x. So similar formula is for partial derivative with respect to y, only difference is here the derivative is with respect to y. So the remaining function or remaining formulas we will discuss in the next lecture. Thank you.